An electric circuit is an uninterrupted, conductive, complete, and closed path through which electrons flow from a source of electric power or source of energy through a device. Source of power, that is battery, and through a device, that is bulb or any other appliance, and returns back to its source to complete the flow. On connecting the electric circuit to a battery, electrons flow from the battery's negative terminal through one or more electrical devices like bulb, motor, etc., for example, and then flow back to the positive terminal of the source of the power, that is the battery in this case. So conventional current is from positive to negative, but the current, actual current is electric current, electron current, that is from negative terminal to the positive terminal on closing the switch. Classification of these happens on the basis of different ways in which circuit has can be wired. So here the switch is on the switch when the switch is closed, the current flows, that is electron flow is shown here, negative to positive terminal of the battery through the light bulb when bulb is lighting up. So circuit can be wired in different ways, that is in series or in parallel. Like resistors are connected in series and parallel in the same way to achieve the different combinations. We can connect the circuit, the cells in series and parallel both, depending on the requirement. If you want to increase the EMF of the battery and you have the cells of smaller values, so you can connect them in series to acquire greater EMF. And in parallel, the current divides and it makes its way through two or more paths. So, Assalamu alaikum. So today's video is made on arrangement of cells in series and parallel. First, we will discuss the arrangement of cells in series. So when we have number of cells and they are arranged in such a way that the positive terminal of one cell is connected to the negative terminal of the other, and then again the negative terminal is connected to the positive terminal, and so on, then we can say that the cells are connected in series like this. Here, three cells are shown, each has EMF E1, E2, and E3. These EMFs can be different and they may be same. If suppose the cells have the same EMF, identical cells, and each cell is of 1.5 volt, then the total EMF here will be E1 plus E2 plus E3. That is 1.5 plus 1.5 plus 1.5. The answer will be 4.5. So we can connect as many cells as we need to increase the EMF of the battery. Here we have single cell, and this is the symbol of the single cell. That is the longer line here shows the positive and the shorter line shows negative. How do we connect them in series? The cells are joined. The negative of one is connected to the positive of the other, and the symbols like this. Positive sign, negative sign connected to the positive of the other. So total EMF will be added. But if we connect the other way around, that is, we join two negative terminals. So what will happen? Negative and negative are joining. The resultant EMF will be 0 if the two cells are identical. Suppose each cell is 3 volts, so 3 minus 3 will be 0 volt. If EMF is different, then the resultant EMF will be the difference of the two in simple circuit. Otherwise, we can apply a Kirchhoff rule to find out the unknown EMF or combined EMF of the circuit. Here, the two negatives are joined together and resultant EMF is 0. In the same way, we can have two positives joining each other. And again, in this case also, the resultant EMF will be, total EMF will be 0 if the two cells are identical. Okay, because they will draw current in the opposite direction. Now here some more explanation. Arrangement of cells in series. Here three cells are shown and EMF of each cell is 3 volt. So what is the total EMF? Simple addition. As was shown in previous slides, 3 plus 3 plus 3 is 9 volt. In the second figure here, four cells are connected. Three cells are connected in a right way manner. That is, the negative of first cell is connected to the positive of the next. Okay, in the same way, the second cell has its negative connected to the positive of the third, but the fourth cell is connected the opposite way. That is, the negative of the third cell is connected to negative of the fourth cell. So resultant EMF, these two cells, the EMF will be cancelled out. Plus 3 minus 3 you can say in simple mathematics. So total EMF will be 6 volts. Advantages of connecting cells in series. When we wire them in series, that provides higher system voltage and lower system current. So if the current is lower, we can have thinner wire, so that is cost effective. It will be cheaper and it suffer less voltage drop across the components in the circuit. And again, this depends upon the requirement of the external circuit, whatever is connected. Disadvantage of the combination of cells in series, that is the resistance. The resistance also increases because in series, you remember that was discussed in one of the previous slides, that is resistance of the series circuit is the simple addition of all the resistors R1 plus R2 plus R3. In the same way, cells can also have internal resistance, so their resistances will also be added, and that will cause more increase in the total resistance of the circuit. Okay, and the second problem with the series combination is what? That is, when one fault occurs, the the whole circuit will break, no current will flow. Parallel arrangement of the battery cells. What happens when the cells are arranged in parallel? So what happens? How do we connect them? The positive of all the cells are connected together and negatives are connected together. Positive of one cell is connected to the positive of next. Okay, and negatives are connected together also. So this is the diagram which is showing the positive connections. All the positives are joined together and all the negatives are joined together. So here the net EMF will be equal to the EMF of single cell. Here it is not added up. Then what is the advantage? The advantage is what? The internal resistance decreases because in parallel circuit, how do we find out the resistance? That is 1 upon R total is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. So the result is what? Decrease in total resistance. So in parallel combination, the net resistance is less than the resistance of single cell. I'm talking about here the internal resistance of the cell, not any externally connected resistance. If the EMF of each cell is identical, then the EMF for the battery combined by n number of cells will be equal to the EMF of one single cell. Here, this is the diagram which shows the connections here. That is, all positives are joined and all negatives are joined. So suppose if the EMF is 3 volt, what will happen? If the EMF of each cell is 3 volt, the total will also be 3 volt. Like if this is 3, so this is a combined 3, this is plus terminal and minus terminal. How do we connect something in this? This way, we will have one switch. This is the switch and the component which has to be operated using this combination, and that is connected to this. If you connect a voltmeter in the circuit, that voltmeter will show 3 volts. It will not be added up, but the internal resistance will be calculated by 1 upon R total is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That will result in decrease in resistance. Internal resistance will be decreased. Whereas in series combination, the internal resistance increases. So that depends upon the requirement. Sometimes when we need more EMF, then of course we need to connect them in series to acquire greater total voltage. But what is the advantage if the EMF is not increasing? If EMF is not increasing, then what is the advantage? That is, the total resistance decreases, and moreover, the cell works for longer time. Okay, they last longer in parallel. They continue providing energy for longer time. Here, there is some calculation shown here. If suppose two cells of 12 volts and 50 amperes into R are in parallel, then the total volt still will be 12 volt, and two 12 volts are in parallel. So, total will be 12 volt, but the amperes will be double, that is 10 ampere into R. So, the battery will last longer. What is the disadvantage? That is the higher current. Okay, and it indicates it needs three thicker cable. Okay, so thicker cable will be of course expensive, and a larger current means more IR drop in the external circuit. I into R in series circuit, because in series combination of cells the current is smaller, so IR in external circuit will be smaller. Here there is some questions shown here. Here you have to find out the voltage. EMF of each cell as is indicated in the question is 3 volt. So what will voltmeter V1, V2, V3 and V4 show? So in this case, voltmeter V1 is connected across two cells, and this is connected in a right manner. And suppose this is positive terminal of the voltmeter and negative terminal of the voltmeter. Voltmeter, in order to measure the EMF, the positive terminal of the voltmeter is connected to the positive side of the solar battery. Okay, so here V1, 3 plus 3, V1 will show 6 volt. What will V2 show? V2 is connected across cell. Suppose this is cell A, B, C, and voltmeter V2 is connected across B and C. So, but the two cells are connected in opposite manner. That is, the negative of cell B is connected to negative of cell C. So, the resultant EMF will be plus 3, minus 3. So, that will show 0. So, V2 will show 0 volt. What will V3 show? If this is the positive side of V3, voltmeter 3, and it is negative side, then this one will show minus 3 volt. If we have connected the other way around, that is, the voltmeter has its negative terminal connected to the negative of the battery, negative of the cell, then this will show plus 3 volt. What about voltmeter 4? Voltmeter 4 is connected between point A and point C. This is also point C, common point. Okay, so here two EMFs are cancelled out because they are connected oppositely, and this voltmeter V4 will show only 3 volt. It means V1 is showing the largest value of EMF. So here the cells can be arranged in different manners, and these are the simple arrangements, and this is for O-level classes. And for A-level classes, of course, the arrangement will be more complicated, and that can be solved by Kirchhoff. Here we can simply, because all the cells are identical, so we can solve them simply. Now there is another question. You are provided with 5 cells of EMF 3 volt each. Arrange them in series to obtain net EMF of 15 volt, 9 volt and 3 volt. First part 15 volt, and there are how many cells? 5 cells, and all of them are to be used. This is the condition. That is, all 5 are to be used. So 15 is multiple of it comes like 3 fives are 15. So it means simply you can connect 5 cells in series to get the EMF of 15 volt. 3 plus 3 6 plus 3 9 plus 3 12 plus 3 8 15. Okay, so the first part is easy. We can obtain by connecting them simply in series. In second part, 9 volt, and all 5 are to be used. So what we will do for the second part? 1, 2, 3. We have got 9. Now what do we do with other 2? What we will do? We can connect other 2 in parallel to the third. So in parallel combination, EMF remains the same. So this is how we will connect 3, 3, and these 3 are in parallel. This is also 3 volt. So 3 volt. So total is 9 volt. What about the third part? You have to get 3 volt out of them. So EMF remains same. So this is again easier one. You have to connect all 5 of them in parallel to each other. So how these will be connected? We will connect all 5 of them in parallel to each other. So this will be the arrangement. 1, 2, 3, 4, and 5. So this will be the arrangement. So here I'm adding one more part. How will you get the EMF? Suppose you have 6 cells. I'm making a little change. And I want you to obtain the total EMF of 6 volt. So what will be done? And you have to use all 6 cells. So this is the possibility. This is an additional part. 3 and 3 is 6 in series. 3 and 3 is 6 in series. And they all are connected in parallel. Now all 6 are used. So 3 and 3, 6, 3 and 3, 6, 6, and this 6. And 6 in parallel will give us 6 volt. So we can arrange in different manner depending on the question asked and number of cells provided and what is the EMF of each cell. Okay, then this is enough for today, and we will meet each other inshallah in the next video. So till then, Allah Hafiz.